Hey, good morning, guys. I am set up at school with my green screen, hoping to record and make this short as I can on refresher on dividing, polynomial long division, and synthetic division, and then we'll do a part 2 where we talk about why we use this. Okay, so it says you can divide polynomials by using either long or synthetic division. The process of dividing polynomials using long division is similar to that in arithmetic, where you divide, multiply, subtract. To set up long divisions for polynomials, be sure the dividend is in standard form with placeholders for missing terms. Synthetic division is a shortcut and it only works if the divisor is a linear x minus c, so x plus or minus a constant. Okay. I think I just went over that. So that was not effective, but you can reread it if you need to, or pause, sorry. All right, here's an example done. And you can just look at this in your notes. I'm not going to talk about it other than maybe this would be a good time to review the vocabulary with you. So let me turn that annoying sound off and get my tablet working. All right, so when it asks you to divide this by this, okay, this is the divisor. What is being divided is called the dividend. And your answer up here is the quotient. And when you write your answer, you write the quotient polynomial plus the remainder over the divisor. Unless it says that you can just leave it as a remainder or something. All right, so that's just some vocabulary I will be using. There is an explanation of synthetic division, and I'm going to show you some of those in a second. So here's our first warm-up. We'll see how I do. We have 13 into 5467. By the way, the SAT has a new calculator part, and you could very likely have to multiply and divide some fairly large numbers for that part. So it's good review. All right, 13, let's see, goes in here. Twice would be 26. 4 times would be 52, I believe. So 13, let's see, 4 times 3 is 12. Carry the 1. 4 times 1 is 4 plus 1, 52. All right, then we subtract. Very important that you remember this is subtracting. We bring down the 2, or we subtract and get a 2. We bring down the 6. 13 goes into 26 twice. So 13 times 2 is exactly 26, and we're subtracting. Okay, we have 0 left. We bring down the 7. Now, 13 does not go into 7 at all. So 13 times 0 is 0. And then we subtract and get our remainder. But because there was a place here, we still needed to put that 0. That doesn't happen super often. In polynomial division, it doesn't usually happen. So we have a 4, we have 420 plus 7/13, or we could just write it 420 and 7/13, but when it's a polynomial, you need to put the plus in. I want to remind you how you check that. To check this, you multiply quotient times divisor plus the remainder. So I'm just going to go over here. You do 420 times 13 0, 6, 12, then placeholder 1 times 0 is 0, 2, 4, you'd add, and then you would add the 7 that was the remainder, and you'd get 54.67, which should be the dividend. Okay, that's how you check. All right, moving on to long division. Okay, we're required to do long division on this problem. We can't do synthetic division because there is a coefficient here. So we're going to write 2x minus 1 into 2x cubed plus 3x squared minus 8x plus 3. If there had not been like a linear term here in 8x, you would need a 0 placeholder. You have to make sure every power is here. If you start with degree 3, then you have to degree 2, degree 1, degree 0. In other words, you need placeholders if any of those are missing. All right, then we look at just the first term and this first term. You need to make 2x squared multiply by something to become exactly 2x cubed. So we would need to multiply by an x squared. Then you multiply this by each of these terms out here. You have to distribute it to both of those terms. So 2x times x squared is 2x cubed. X squared times negative 1 is negative 1x squared. Then here's where we run into trouble because students forget they're subtracting. When you subtract, it's easy to remember to subtract here, but you are also subtracting this term. I gotta tell you, Hofbauer usually changes this to plus and then changes both of these signs so that I can remember to add these back here since I distributed the negative. This becomes 4x squared. You either have to remember you're distributing a negative or actually distribute it. Okay? And then bring down this guy. Then you're starting over. You're looking at this first term and this first term here. So to become exactly 4x squared, a 2x would need to multiply by a positive 2x. So 2x times 2x will become 4x squared. 2x times negative 1 will be minus 2x. Then we are subtracting this quantity, or we can do plus, change the sign here, and change the sign here. So this will become 0. But negative 8x plus 2x will be negative 6x. And then I'm going to bring down this plus 3. And then I'm going to move myself somewhere else. Now 2x, one more time, to become exactly negative 6x would need to multiply by a negative 3. And then I'm distributing that all the way over here. So negative 3 times 2x is negative 6x. Negative 3 times negative 1 is plus 3. Then I am subtracting or adding the opposite. So this will become plus positive 6x, which is 0. And this, when we distribute the negative, will become a negative 3. 3 minus 3. This is also 0. So there is no remainder. So our quotient was x squared plus 2x minus 3. All right, I'm going to do a check real fast just to show you. X squared plus 2x minus 3. If I were to multiply it by this divisor, 2x minus 1, so I'm going to distribute x squared times 2x is 2x cubed, x squared times negative 1. Then I'm going to distribute a 2x back here. I get a 4x squared minus 2x. Then I'm going to distribute this negative 3 back here. I get a negative 6x plus 3. If I combine like terms, I'd have 2x cubed plus 3x squared minus 8x plus 3, which thankfully is what we started with here. So there is our check, okay? That's just a check. You don't have to do that. But if you're taking a test or quiz, there's a great way to make sure you're getting the right answer. All right, we have another one with a lot of terms here going on in both the divisor and the dividend. So we're supposed to divide x squared plus 3x minus 4 into 2x cubed plus 5x squared minus 7x plus 6. Double check in, we have degree 3, 2, 1, 0. We don't need any placeholders on this one. So x squared needs to become exactly 2x cubed. So I need to multiply it by a 2 and an x. Then I have to multiply that by all of those terms. So I get 2x cubed, 2x times 3x is plus 6x squared, and 2x times negative 4 would be minus 8x. Then I need to subtract all of that, or I can change it to add negative, negative, positive. Now I'm adding because I changed all the signs. So this is 0. This is negative 1x squared. And this is plus 1x. And I can bring down this 6. Okay, only have to go one more time. Now I need x squared to become exactly negative 1x squared, so it would just need to multiply by negative 1 to distribute that negative 1 to all of those terms. So I get a negative 1x squared minus 3x plus 4. Then remember, you are subtracting all of these, or if you want to think of it that way, adding the opposite. I find that as long as you write neatly, that is a great option, is to change the signs. So this adds to nothing, this adds to 4x, and this adds to 2. Now, 4x would not multiply by anything to become, or x squared, I'm sorry, would not multiply by anything to become 4x other than 4 times 1 over x or something. So this is your remainder because it is a lesser degree than this one. So the answer is 2x minus 1 was our divisor, plus 4x plus 2 was our remainder, and we put that over the divisor, x squared plus 3x minus 4. Yikes! Okay, if you wanted to check, you would do x squared plus 3x minus 4 times 2x minus 1 plus a 4x plus 2. I can do that real fast. If I FOIL this together, I get 2x cubed minus x squared plus 6x squared minus 3x minus 8x plus 4. Then I have a plus 4x plus 2. I combine like terms. Let's see. I don't know. Is that what I started with or not? Yes. Okay. So my crazy fast distributing there worked. You don't have to do a check, just showing you how. All right. One more long division. This one requires some placeholders. So we have an x to the 4th plus 3x cubed plus 4x squared plus 24x minus 32. And we are dividing that by an x squared. Now, this is where the placeholder comes in, which is kind of unusual, plus 0x plus 8. You really wouldn't have to have a placeholder there as long as you were careful to line things up. All right, I'm going to go real fast because this is really an extra example. I could have left off the video and just showed you. X squared times x squared is x to the fourth. There's a 0x cubed here. And x squared times 8 is plus 8x squared. Then I am subtracting or adding the opposite. So I end up with bringing down a 3x cubed, and then this is a negative 4x squared. X squared to become a positive 3x cubed would need to multiply by a 3 and an x. So 3x times x squared is 3x cubed. 3x times 0 is 0. 3x times 8 is plus 24x. So interestingly enough, when I subtract both of those, they both drop out, and I just have this to bring down. Now, 4x squared, I can still multiply this by a 4, but I need it to be negative. So if I multiply by a negative 4, I get negative 4x squared, and then I have plus 0x and a minus 32, which is exactly what we had up here. So we get 0 when we subtract, or change it to add the opposite. So this came out even, x squared plus 3x minus 4. And again, you could multiply it by x squared plus 8 and check that you got all those terms. All right. Synthetic division. There's an example on the slide here that shows if we're going to divide by this, the 0, not negative 3, but positive 3, the 0, okay, what would make this 0 is what goes in this little box. Then the coefficients go across the top. We get to leave out all the algebra, just use the numbers, the leading coefficients. 6, negative 25, 18, and 9. Not really leading, all the coefficients. But again, if there's any terms missing, you need placeholders. Then the rule is you drop this down, multiply, add, multiply, add, multiply, add, okay? So it's multiply, add, after you drop the first one. No subtracting, okay, because we're using the 0. All right, so synthetic division here, we need a negative 4 in the box because that's the 0. Across the top, we need the coefficients, but we need a placeholder already. There are 0x squareds in here. So we have to write 1x cubed, 0x squared, negative 28x, and negative 48. Bring this guy down is a 1. Then it's multiply, negative 4 times 1. Okay, you're multiplying here. Negative 4 times 1 is negative 4. Be really careful. It's super easy to make a mistake with signs or adding. 0 and negative 4 is negative 4. Multiply again is positive 16. Add, watch your signs. This is negative 12. Multiply again by this negative 4. And you get positive 48. So we have a 0 here. All right, this last one is always your remainder. And because this remainder is 0, it means x plus 4 is a factor. It came out evenly. It had no remainder. But this answer over here is a polynomial, and you start with the constant of negative 12, then you go backwards and you add a linear term, so that's a negative 4x. You go back one more and you add a squared term. So from the back, you have constant x, x squared, x cubed, until you run out of terms. So the dividend, or I'm sorry, the quotient is x squared minus 4x minus 12. There was no remainder on this one. Okay. Number 5 here real quick. The 0 is 1. The placeholders, or I'm sorry, we do need a placeholder. There's 0 x's here. So we have 1x to the 4th. Oh, there's also 0x cubes. We have 1x to the 4th, 0x cubed, negative 3x squared, 0x, and 12. All right, then we do bring this guy down. Multiply, 1 times 1 is 1. Add is 1. Multiply is 1. Add is negative 2. Multiply is negative 2. Add is negative 2. Multiply is negative 2. Add is 10, and that's your remainder. Now, the answer we got then is, this is the constant term. This one gets an x. This one gets an x squared. And this one out front is an x cubed. So our answer was 1x cubed plus 1x squared minus 2x minus 2, which should make sense. If you look back up here, we divided an x into an x to the fourth. An x to the fourth divided by an x, we should have ended up with an x cubed out front. Okay. Plus, we had a remainder of 10 divided by, it says write your remainder over divisor. The divisor here was x minus 1. And I'm going to put that in parentheses just to make sure you see it's all in the divisor. So if I wanted to check that again, I take x minus 1 times all of this and add 10, and I should get back to x to the fourth minus 3x squared plus 12. All right, I'm going to stop. This is the video of dividing, both long division and synthetic division.